All right, today in Core 3, we looked at another real-life example problem relating chords and circles to the real world. We did a bit of other stuff going over the past quiz and everything, but wanted to focus on this for this video since it will help you for tomorrow's quiz. Now, the diagram we started with looks like a pretty complex one. Okay, by the way, I'll put the page number on here. Out of the book, it's on page 403, and it's the Check Your Understanding problem. You'll recognize the diagram if you flip there. Now, you start with a circle. Now, within that circle is quite a bit. First of all, we have another circle that's about half the diameter. Oop, lost my spot. Not too hard to get it back. Apparently hard to keep it there. All right, now, between the big circle and the small circle, we have a bunch of chords, which if you look closely, turn out that they are a bunch of squares. So I'm going to do my best trying to sketch those here. Now, if it doesn't come out perfect, it's not the end of the world. Which, definitely not going to. There's one. The other one is offset a bit from it. Sorry, I'm moving it all over the place trying to draw these. I'll show you where I'm at after this current one. There's two, and we got one more. And there's three. So definitely not exactly what it is in the book, which I'll show you here real quick. But it's close enough. Now, the book tells us a bit of information about it. First of all, it tells us that, well, this is a designer wheel cover. So that's why it looks kind of weird. We have some wires that are going around the wheel. Second thing it tells us is that the wheel itself has a diameter of 12 inches. So I'm going to go ahead and pick one of my squares, which should be a square. I'm going to cut it in half. We'll say that is 12 inches. Now, it also says the wires, which are chords, are shown are all equal length. So if I look at these, every single one of these chords should, if I drew it correctly, have the same length. So I'm going to label them X. Now, since those are the ones I'm using, I'm going to see if I can highlight that blackened side with the red. So it stands out a bit more. Now, first question asks us, well, what is the length of a chord? Now, if we just sit here and stare at this diagram, it's going to get really confusing. So what I want us to do is to take the triangle that we just created and separate it. Now, there's our triangle. This is our X. This is our other X. And this is 12 inches. Now, we need to know a little bit more about this triangle. to make sure we can solve for the side lengths that we're missing. First of all, in here, if these are all the same length, and these are all squares, being the corner of a square there, it means we have a right triangle. Now, a right triangle that has two equal side lengths is a right isosceles triangle. What that means is that both its angles are equal. Now, if all the angles of a triangle add up to 180, and we take off the right angle, it means we have 90 left to split between two equal halves. So 90 divided by 2 is 45 degrees. Now, to actually solve for x, we can do this a bunch of different ways. First way I want us to look at is SOHCAHTOA. And I'll try and put it on here so you can see everything. SOHCAHTOA. Sorry, there's an announcement going on.
Jalen Munoz, please come to the main office. Jalen Munoz to the main office.
Now, because both of these are 45-degree angles, I don't have to worry too much about which one I choose. Hold on, it's getting a little blurry. I'm going to try and fix that. There we go. So I'm going to say, let's say I'll change colors for this. We'll say this is going to be my theta, the angle I'm focusing on. So sine of my theta, 45 degrees, equals opposite, which is x, over a hypotenuse 12. Cosine of 45 degrees will be adjacent, which is x, over hypotenuse 12. And then tangent of 45 degrees equals opposite over adjacent, x over x. Now, the only one there that doesn't really make much sense is our tangent. Sine and cosine should be easy to solve. Now, we've looked at this before. Our shortcut for the algebra is we can flip that 12 out front, flip the 12 out front. So now all we're doing is 12 sine of 45 and 12 cosine of 45. Now, I pick a random student, have them do this. So Leonardo wanted a shout out in my next video, so I would say, Leonardo, what is 12 times the sine of 45? Now you go ahead and type it in, hit enter, and there's our answer, 8.48. Now, I would go again, Leonardo, is that the same thing as 12 cosine 45? So he would type it in, hit enter, and once again it's 8.48. Which is as it should be. So both our chords are 8.48 and 8.48 inches. Now, that's not the only way to solve it, but that's the only way I want us to focus on now so that we can not overly complicate it with too many ways to solve it. There will be a problem like this on tomorrow's quiz, so hopefully you can follow these steps. Thank you for watching.